The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of Hawaii Tracker, bringing you guys another Hawaiian Volcano Tracker update. Today I'm calling it that because we're going to do Mauna Loa first, then Kilauea. As you can see here on a screen, a trace of the earthquake swarm happened on Mauna Loa a couple days ago, as what caught everyone's attention here on island and probably elsewhere as well. So we'll talk about that first and then some detail for the context. Then we'll turn to our regular Kilauea monitoring update, lava viewing, gas emissions, all the usual stuff we typically do, volcano watch. And at the end, we'll present a replay of the Volcano Awareness Month presentation by Frank Trusdell that was given in January this month, entitled Mauna Loa, Are You Ready for the Next Eruption? So we'll do quite a bit more Mauna Loa today, some preparedness at the end there. We're going to leave that video for the end. It's about 20 minutes at the end. And until then, we'll go through our regular discussions, presentations. Dana will be taking questions, leading a discussion on the chat. So let them know if you have any issues with our audio or video, or if you have some questions you'd like us to address and bring up for discussion as well. Anything you want to start off by saying, Dane, this week?
No, not much. I mean, I'm interested to hear what you have to say fully about Mauna Loa as well. We have seen Mauna Loa do pump fakes before, and I've called it the pump fake king. So, it's always interesting to see what these movements mean, and it's about patience sometimes with Mauna Loa. But yeah, it's kind of all I got to say. I'm interested to hear what you got.
All right, so we'll start off by doing earthquakes all around. We'll kind of do the big picture of the island and then kind of come into Mauna Loa. So let me switch over to our recent earthquakes as our first segment today here. This is a trace I pulled from a station at Mauna Loa Summit, showing that seismic storm that occurred overnight on August 2nd local time here. But first, let's switch to what we normally look at on Kilauea. We normally look at the earthquake counts for this map on Kilauea, and just to put things in perspective, this is quiet on Kilauea, not a whole lot at the summit, not a whole lot in the south flank, or Pahala still going off a bit there, but all within the regular ranges we've seen. There's nothing abnormal here. I just want to make sure we cover this before we move on to Mauna Loa. As far as the rates, here is the last year for Kilauea. You can see here down at the right end. Oh, looks like I don't have my Madden pen is not lined up here. Let me get it turned on. Right. Okay. So right here at this right end, we're at these low levels that haven't changed really since, we had a little bit of a flurry earlier in January this year, but really Kilauea has been in this normal pattern of when it's erupting, there's really not a whole lot of reason for it to be catching and quaking elsewhere unless some big batch is coming through. We haven't seen anything abnormal, nothing unusual like that. So Kilauea is all good, basically, right? Zooming in on Kilauea, here's the last month. Nothing abnormal there as well. We can see we're around 40 earthquakes per day, 30 to 40, that's the normal range there. All right, so moving on from there, here is our earthquake map for the whole island. We do have one offshore, closer to Maui, 3.4 at 8 kilometers depth. That was likely felt on Maui. And a couple on Mauna Kea here, 1.8 at 16K down, 2.6 at 23K down. Those fit into that settling pattern of earthquakes under the older volcano there. Likewise, 2.8 near Puako at 22K down, and what's this one over here? 2.4 at 18K down as well. All right, so we've looked just now at Kilauea and this quadrant over here. Everything is good there. Pahala is still happening, right? We can discuss that in more detail again in the future as we get more information and more data. But really what's on this map that we're going to focus in on is this linear cluster right here at Mauna Loa Summit, right? There's a little bit here to the northwest where we often see those signals, and still have a little bit of these background lower flank events. So here's a 6.2 kilometer deep, 1.8 on the southwest flank, and a few more on this northeast flank right over here, right? We're most recently 2.2 at 2.5K down, but also 2.1, 2.3, 1.7, 1.7, and what's that last one there, 1.8. So if I zoom in closer and closer and closer, that's Mokoa Ve'oveo, that's Mauna Loa's summit caldera right there. And so you can see mostly in the summit caldera area, but also spilling over a little bit into this upper southwest rift zone. Now that's normal also. The summit cloud often extends there to that upper southwest rift zone, especially in recent years. So to kind of put things in perspective for you guys and give you guys all the context you really need to understand how this fits in, we're going to start off first with the official USGS update here. Mauna Loa is not erupting. It still remains at alert level advisory aviation code yellow right there. They're officially, here's what it says. The rates of seismicity temporarily increased above long-term background levels in the evening of August 2nd, 2022, and return to background levels by the morning of August 3rd, 2022. Other Mauna Loa monitoring data streams, ground information, gas concentrations, visual appearance, and webcams show no significant changes. So here are the observations. During the past week, HVO seismometers recorded approximately 206 small magnitude earthquakes, that means below magnitude 3, beneath the summit upper elevation flanks of Mauna Loa. The majority of these earthquakes occurred at shallow depths less than 9 miles below sea level. Of those 206 earthquakes, 90 were part of an earthquake swarm that occurred beneath a caldera from approximately 5:20 p.m. on August 2nd until 3 a.m. on August 3rd. Most of these occurred around 2 miles down, beneath the surface, it says, right? The surface, not sea level. We'll get into that a little bit later. And the largest event in the swarm was magnitude 2.8. During the swarm, a minor tilt increase of 1.5 microradians was observed on one tilt meter, MOK at the summit, though a small part of the signal includes normal diurnal effects. We'll look at that signal as well. GPS measurements show steady rates of deformation in volcano's summit region, continuing through the past week. Really nothing's changed there. So here is the money line of this update today. This activity is a relatively small increase in volcanic unrest and remains within a range of fluctuations observed over the past several years. So let me just pause there and just, note, they are noting that this is an increase in volcanic unrest, albeit a small one, relatively small one, right? And within a range of what we've seen in the past several years. Prior to this activity, the most recent earthquake swarm beneath Mauna Loa summit occurred in spring of 2021, producing about 1,000 earthquakes over a span of 7 weeks with a peak seismicity rate of 40 earthquakes per day. So 40 per day, not as much as our 90 we just got, but also it lasted for a lot longer, right? So one question we may have is, have we seen the last of it, or is this just the first flurry of what may be a change in a pattern of activity? And we'll have to wait and see. Time will tell on that. So otherwise, concentrations of SO2, H2S, CO2, and fumarole temperatures are both stable and no changes visible on webcams. That's all the official information from USGS there. So we'll dive into it a little more. The first question is something happening at Mauna Loa. Here's a webcam of the summit for the last 24 hours. And apart from the typical exposure of the wind and the altitude, there's not anything happening there. So here's a nighttime shot, totally black. Related, if there was a chance that lava would have made the surface, it's without putting out any other signal, it's not showing up in any webcam. So there really is nothing, had led to nothing yet, I would say, right? Because the key thing to remember is that volcanic processes can really extend over geologic time, right? So, not to say that earthquake swarms going to last like our whole lives or anything like that, right? But just that these things can be long, extended, kind of slow motion developments of how these systems evolve over time. That's something we've seen before. So here's the IRIS earthquake browser showing this sequence, and I don't know if you can really see here on a bottom down in here, there's a little graph of over time from the second to the third, earthquake counts coming and rising and falling. We'll show you other versions of that. And this doesn't like that I zoom into it, but if you look in here, you can see how those earthquakes propagated across time. They kind of came in one big flurry right there overnight on the screen, and then slow back down again. And so that's what it looked like temporally. Let's look at the map. Here's the map of the last week of earthquakes. So that gives you a pretty good idea of where these are situated, right? As we pointed out already. And notice that there's not a whole lot happening in this northwest quadrant here as part of the swarm. It's mostly over right in the summit area, more so. Right? So that's interesting. What we're going to do is offer some context. This is the last week. Let's flip to the last month. Here's the last month. So over the last month, we see that we did have some of these northwest quadrant earthquakes. If we go back to the last year, here's the last year. So we see that northwest quadrant is quite active, that there are other earthquakes that fit into the summit pattern, but they're, didn't occur all at the same time as the one we had this past week. But you also see all these small events over here on this right side. That's all this southeast flank as it's moving away off in that direction, similar to what Kilauea does. So one more frame, here's the last 5 years. So you can see that earthquakes in Mauna Loa are actually pretty normal. There are a lot of them. They can be alarming, but as Dane mentioned, right, a lot of times they alarm us and then we quickly come back down and get alarmed and come back down. So the pump fake, as he's calling it, right? It's quite common for there to be flurries, and the last eruption of Mauna Loa was 1984. So really, nothing's happened in the last 5 years eruption-wise, and you can see how many earthquakes we've had here, and also which areas are the most active, right? So clearly the summit area is very active already. So we fit easily into that pattern. There's nothing kind of different happening apart from that. And to offer you a little bit of why that is the case, here is an old cross-section of Mauna Loa. The caldera, let's see, I have to scroll this down a little bit here. Here we go. There's that summit caldera right up there. Right? This little notch put into the ground right there. And the idea is that there is this zone A, somewhat of a smaller magma reservoir that sits higher up in a volcanic edifice, and then fed by this zone of this long dike that kind of goes throughout the whole volcano. And what they've shown here is that zone to the northwest is a little bit deeper and often occurs off to the side here. So it's thought that as this reservoir and network area inflates and magma is coming into it, which it has been doing really for a long time now, really since the early 2000s, that it basically is pushing right, pushing to the side, and then you see the pressure of this as it's pushing out in every direction. This area seems to be the one that actually shows earthquakes, and for this reason, for some reason, this one over here doesn't, right? Possibly because this whole flank is able to move off to the side, but this one doesn't. It catches, and so we see this expression here to the northwest. And here is this cluster of earthquakes that occurs basically directly above the magma reservoir and beneath the summit caldera. So you see right in there, that's that area that we are looking at. So basically right over the barrel of the gun, so to speak, of where the magma is coming up in the volcano. So coming up through here, it often will stop in here, but it's not inconceivable that the magma actually went a little bit further and got somewhere up into the regions in here over the last couple of days. And that also is normal. That's what volcanoes do, is they fill with magma. We've been trying to get a better estimate of how much magma is actually filling the volcano passively without erupting, compared to how much actually comes on the surface and coats it and erupts and grows it in that manner. The best order of magnitude we're getting at is about 50-50, right? So you imagine like something, some amount of magma is always coming into the volcano and always growing it from inside, and it kind of can spread and sprawl outwards and just kind of grow inside. And only when it cracks enough will it actually squirt out, right? So it's growing in this more passive fashion now, filling with magma, significant amount, right? I think we've found that basically the amount since that's filled in the summit of Mauna Loa since 1984 is a little bit more than what erupted in 1984. So that goes to show that the amount of magma is actually comparable there as well. So that's what it looks like in cross section. A little bit more detail. We can actually go to the USGS page, and we can activate the earthquakes, and we can zoom in and do the earthquake plot and select a cross section. I did all of that, and I took a screen cap because I didn't want to risk it breaking on me live here. So here's the area that we have for our cross section. Right, there is A up here, and here's B down here at the bottom. And here we're looking actually at time on this bottom axis, right? So we're looking at this was 2 days ago right here, and then this is a week ago back over here. So, and then over here it's the depths. The depths are shown in miles, and this is showing negative because it's above sea level, right? So this is actually 3 kilometers above sea level, 1 kilometer above sea level, 1 kilometer below sea level, 3 kilometers below sea level right there, right? So, and the coloration of these dots is basically just time. So you can see everything that's white is older than that period of time, and everything that's yellow is older than that, and the orange is just in the last few days here. So what you can see is the range of depths of these earthquakes, right? Most of the cluster occurs up in, let's call it right there, from there to there, right? So when USGS says it occurs about, what did they say, 3 kilometers beneath the surface, they're talking about 1 kilometer above sea level. That's right here, 1 kilometer above sea level, the center of this swarm, right? So 1 kilometer above sea level, by the way, is if you're standing on Kilauea. Right? Kilauea is about 1 kilometer above sea level. If you're standing at Kilauea and looking at Mauna Loa, right there at that eye level, that's where these that's the center of this spot right here. So you can see that if that was magma that was moving up and through there, it was coming from below that eye level and then coming up above eye level as you see it from Kilauea, right? And getting pretty shallow up there, right? Not quite to the surface. You see not quite to the surface there, right? We didn't actually see any tremor or anything like that visible that would indicate any surface activity. But you can see it was working its way shallower than it often does, right? So that's a pattern that you look for, this vertical span, right? And if you were to zoom into it, you might possibly see over time that it might get shallower as time goes on, like slightly leaning to the side kind of thing. But we don't have that resolution in here. It's hard to really tell. And there can be multiple strands, and so it gets complicated there. Overall, we're fitting a pattern though. So it's consistent with, we don't know for sure, consistent with some injection of magma into that shallower reservoir area from that deeper part of the volcano there. You can see some earthquakes down all the way to 3 miles, right? That's about 5K down here, but not nearly as many. And so it's possible that you have some knock-on effect, domino effect, where if you move stuff up here, you might pull some stuff from below, or you might have stuff from below pushing from above. It's hard to tell if it's just this without the sequence in more detail as well. So we really need more information to tell us exactly what changed after the fact. We can see like what actually happened, but what's changed, what's the result of it. We have heard people asking for INSAR. We'd love to see some INSAR as well. We'll continue to pass those requests on and see if the USGS maybe will release some INSAR and explain what's going on up there to us a little bit. But I would expect to see continued inflation of that summit area, especially, right? Considering the layout of this, right? When we look at this cross section, most of the earthquakes being more so in here and less so over here, right? If we look back at this section, most of the earthquakes are here and not over here. So it's an upward push that we're seeing. That appears to be the case. So earthquake rates here the last week on Mauna Loa. Here is that overnight second to third right there. So you get a little bit on a second and a little bit on a third, and really coming up a little bit. We really saw this last week, how these rates have been coming up a bit, but they're really spiked, so to speak, in those days. And so we'll zoom it out from the last week to the last month. So here it is in the last month, hitting almost 100 earthquakes in that single day, right? That 90 swarm count right there. Back to 40 yesterday, and today's value is still tallying, but it's going to end up around 20 by the looks of it, something like that. So it's crashed back down. So really within the last month, clearly this is abnormal, right? It's the only big peak on this whole graph. Let's go back to the last year. So here we are in the last year at the right end, and you can see that we actually are at earthquakes per week, somewhere close to 200 here, the week not quite over. And that exceeds what we've seen in the past year. We had somewhere around 160, 170, something like that, back in February on Mauna Loa. But that wasn't a whole lot happening then. We've exceeded it, and we actually can zoom out one more time to the last 5 years on Mauna Loa. So now we're at earthquakes per month as our scale here. And so our month now is actually down over here. And you can see that this level of about 400 per month is something that we came up from, right? But actually before March, back in the early days of 2022, there were 3 times where we reached similar monthly counts right there. Right? Going back to spring of 2021, you see that even though we had fewer earthquakes per day, that they went on for long enough, they actually added up to these really high monthly counts, right? Where we got close to 800 for 3 months in a row there. Like 800, maybe 700 for the third one here. Now, prior to that, we had peaks somewhere around 500, and really it's all ramped up since 2018 is when this change really has occurred, right? So really since 2018, the earthquake rates have come up, and we've had more of these peaks. Really, the whole background level was higher since then, with a few other extraordinary peaks above that right there. So you can see that long-term pattern. So when you hear someone say, I saw a comment come in already from, who was it from? Maybe it was from the dude. I hope we're going to hear that's more than just the background rates coming in here, right? So here are the background rates. And you can see that depending on what we said before, what you call your background rate, if this is your background rate down here, then clearly we're above background rates, right? If you're considering what happened in late 2018 and 2019, 2020 with this rate over here, then you can say we returned to that elevated above background rate area, right? But you can also clearly see that we've seen events bigger than this just within the last couple of years that have not led to eruption. Not to say that something couldn't, but that makes us a little more cautious, we'll say, right, with seeing any little event and jumping to cry wolf. So it's not time for anything like that yet, and we're putting it all in perspective for you guys right now. Still, like I said, it could lead to more activity. We'll have to wait and see. You know, this is only one day. It could be that after a couple of days off, it picks up and goes for several weeks. We'll see. But for some context, historically, 1975 was the last eruption at the summit, and we expect the next eruption of Mauna Loa will be at the summit again. So here is earthquakes per day, starting in April 1974, and going over a year until the eruption in late 1975, right? And what you can see is earthquakes per day are actually labeled 500, 1,000, 1,500. So we actually hit 1,500 in 74, and you got over 1,000 several times, close to 1,000 several times. Now on our scale of earthquakes per day, we just got to 90, so we're probably down here, 90, something like that. So it could be that we're seeing something like that, right? That's possible. Or it could be that we're seeing what was before this, which is just tons of nothing for a long, long time, all the way back. So it could just be this regular adjustments. But you'd have to see, I'll show you this to show what you'd have to see for us to actually be more concerned would be this climbing rates and then peaking up much higher consistently like this. Right? And you see that even in 1974 to 75, it took over a year of this happening before that summit eruption actually occurred. And not to say it's going to happen in the same way again, but we are often informed by the past for what to expect here in the future. So we expect at least earthquakes to ramp up for some amount of time, maybe not a full year, but for some amount of time. And this could be the start of that, but it is just a little blip so far, right, to be honest. So that is the seismicity context. Let's look at the monitoring data on Mauna Loa. And let me switch my title here so we can make sure that we're addressing all of Mauna Loa, not just these earthquakes. So here is the map of Mauna Loa Summit, and we'll look at two things. One is this tilt meter, MOK, this red triangle right there. And the other thing we'll look at is a distance between the north part and the south part of the caldera, the distance of this line that goes back and forth right across here. So that is what we'll be looking at first. Here is the tilt for the last week at Mauna Loa. Now what you normally see is what the USGS has called this diurnal cycle, what you see the every day, twice a day cycles, right? Just like the tides here. And similar causes, right? So you see that solid earth tide occurring here, and then two components, blue and green, are just kind of two different orthogonal directions. Right? One pointing northeast is the green, and northwest there for the blue. So in a northwest direction, you can see it took a jump right there. It was coming up already anyways, but this is obviously offset from down here, right? That's the offset right there that we're looking at. So that's the jump we saw in the tilt, just a little bit, which is interesting to see that. Here it is zoomed out for the last month, so you can see that really most of the time what we see on these tilt plots is it's kind of slow wanderings up or slow wandering down. That's what we normally see on these tilts. We don't usually see it jump up like that. So that's informative for us to know what to look for on these tilt meters as well. GPS across the caldera, north to south. Here is the last year. So you can see there's a bit of spread on the right end of the graph over here. Let me see if I can zoom it in some more. Zoom. Some spread in the graph right over here, but really you have to average it out. There's been spread before plenty other times in the past, like in there, for example. So what really matters is this longer term trend, the line itself. And so that hasn't really changed. You can see that there are times within the last year that it was going slower, right in there, and other times that seem to be going similar. If we zoom it out to the last 5 years, all this upper panel fits in right in here. And that's what we were just looking at. So go back a little bit further and you get to that spring of 2021. We talked about that last big earthquake swarm event that lasted those many weeks. And you can see that in that case, the GPS actually did have this little excursion. Prior to that, it actually contracted, then expanded, and contracted again, right? Contracted, extended, contracted again. Right, and you can see that prior to that adjustment, there was quite a bit of a faster rate of extension north and south across Mauna Loa. So you can see that the rate of extension of Mauna Loa before was faster than it is now. So even though Mauna Loa is still extending and filling, it's doing so at a lesser rate than we saw a couple years ago. And perhaps like the couple years ago sequence, this does lead to some adjustment some point in the future. We'll have to wait and see here. So that is the deformation context. You can look at the vertical as well. It's pretty similar. Everything is still going up. There's a last year and the last 5 years, and similarly you can see that change in rate from extending slowly to extending fast, adjusting a little bit, and still extending. Maybe not as slow as here, but definitely not as fast as here. Well, somewhere in between. Rising, I should say. I have to correct myself here. This is the up vertical, right? So not extending, but rising. Okay. this all fits into this pattern that we see at Mauna Loa. So here's an image that I've pulled from Walter and Amelung that they discuss this earthquake eruption cycle, where essentially what you're having is this alternation between movement of the flanks, whether it's the southwest or the southeast flank, either way. And when these flanks move, essentially allows unclamping of the rift zone and decompression of the magma chamber. So then magma is induced to go from these deeper areas where it's getting squeezed to the shallower regions up in here. And when it's injecting into there, that's when it can vesiculate, and it could lead to intrusions or eruptions, right? That's what's shown over here. This is being presented more so as leading to an eruption, but I think that what we've been seeing, this pattern over the last few years, really has been intrusion, right? Various kinds of intrusions into the volcano, and really no eruption for a long time. So it seems to be able to adjust without erupting at present. So it goes through this intrusion phase, then that allows that pressure to build on the flanks once again, and then you go back to the flanks having to move. So the flanks move, the summit and the center fills up, that pushes on the flanks, they move, and there's your cycle over and over and over again. So that's why it doesn't occur necessarily at a constant rate all the time, but it goes like in pulses. Sometimes you have a bunch of them, sometimes you have nothing happening, like really the last 6 months. So that all fits into this paradigm that we're used to seeing here at Mauna Loa. And that is all we can say so far at Mauna Loa. Like I said, it could be the opening sequence, it could be a little blip. Only time will tell. We can maybe look at some of the questions in Mauna Loa here, Dane, as we're at this point. And I do see, generally speaking, we have a lot of viewers coming over from Iceland eruption, so welcome all you guys who are checking us out. We'll look at Kilauea's active lava here shortly, but first, earthquakes in Mauna Loa.
All right. We do have a couple super chats I want to acknowledge first. One was from our longtime supporter, Gary Bryan, who says, thanks, guys, for the analysis and discussion. All you did to prepare for these updates. Appreciate it, Gary. Appreciate the longtime support. We also have a 1999 super chat from Jan Zhao, who asks, is the volcano on Big Island like the one erupting in Iceland?
It's a little bit different. So, I mean, Iceland has a whole range of volcanoes, and I haven't honestly dug very deep into the one that's currently erupting right now. That just started up most recently here. There can be magma types that are similar to Hawaii and Iceland. They're usually a little bit more evolved. But Iceland has both. I mean, has essentially a full spectrum of kinds of lava that exist. So it's quite possible. The early images that I have seen do seem like it does remind me of this kind of basaltic eruption style, right? So fissures and lava flows similar to what we see in Hawaii. So at first impression, yes, it does seem like it is very similar to that one. Yeah. The difference, of course, is Iceland's has so many different volcanic centers, and Hawaii has less. So there are differences as well. Where we see Kilauea being constantly active for a long, long time, and in Iceland you see kind of one volcano, then another, then another, then another, then another. Some differences there, very generally, broadly speaking.
All right, and then we also have a $20 super chat from Chris Kiki, who says, thank you, Philip and Dane. Appreciate the support there. And a $5 super chat from Sean Huntley, who says, greetings from the Nevada County Home Brewers. Appreciate it. All right, so we can get into the few questions here. Richard asks, are there more earthquakes or seismic tremors when no eruption is happening? I assume that means at Kilauea, maybe.
Well, in either case, what the tremor is really showing you is some kind of fluid moving through some small opening, right? So it's a vibration, like a harmonic vibration. It's not unlike blowing through a recorder or a flute kind of thing. You're forcing a fluid through a small space, and it's creating a vibration there. And that's what the tremor actually is. So normally you see that if you have something like a gas vents billowing out, or an actual lava vent where the lava is going out and the lava is actually vibrating as it's coming out of the vent. So it could be a subsurface movement, or it can be an actual surface movement of the fluid itself. Whereas an earthquake, the regular earthquake that you guys are seeing, like it's shown right here, that's the rock breaking, right? So that can be caused by magma moving, the fluid moving and building pressure, but it's actually the rock surrounding it that's breaking, and not the movement of that rock through that some small opening kind of thing. So it's actually, you have to have a pretty particular geometry for that tremor to show up when it's underground. At the surface, it doesn't matter. If you have a crack in the surface, it's going to vibrate the surface. So you often can tell that as a sign of eruption when lava's reached the surface. So yeah, when eruption is happening, what you see is usually more earthquakes because you don't see as much of the fluid movement underground, to answer the question there.
All right. We do have a question from Dude who says, who asks, this all presumes, we're talking about Mauna Loa patterns, this all presumes that these patterns are required for this or any volcano to erupt. Have they ever been caught off guard, the pattern not telling them everything they needed?
Yeah, I mean, that's a tricky question to answer, and I'll start off by saying that people have only been watching Mauna Loa for a couple hundred years, really. Right, and that really limits how much information we have. Right, that's kind of part one. So, in those early days with very little data, they did try to come up with some patterns, and those patterns were often broken and try to come up with some new pattern, and patterns, for example, of like how long it took between eruptions or those kind of things, right, which is a little dicier. The patterns we're looking for now are the patterns of deformation, so like the earthquakes, the tilt, the GPS, satellite measurements, things that didn't have as much to rely on in the past, right? We did have some of that in 1975 and 1984, earthquakes especially, right? But really, we're now in a modern era of monitoring by satellite, a lot of things. And so it would take something extra for us to be surprised nowadays. And plus, we're not looking at intervals as the kind of patterns. We're looking at the actual filling pattern that wouldn't have been included in the earlier guesses, right? Like, it's hard to guess an intrusion when you don't really know what an intrusion is back 200 years ago, and you can't determine that it happened or didn't happen, kind of thing.
Right. The other thing is just Kilauea has erupted so much in the modern era that we have such refined data on it that has been crunched and analyzed and all that. But like when that intrusion happened before both of these, the 2020 eruption and the 2021, those ones were, it was pretty clear that there was an injection of magma coming in. With Mauna Loa, though, the same type of signal, almost, not exactly the same, but it's somewhat similar. It's like it still has questions around it, just because we don't have that kind of precision around something like Kilauea, especially with just it even goes down to the amount of instruments on the volcano itself around the caldera.
Yeah, the size.
It's more of a wild card than Kilauea.
Yeah,
just by that.
Yeah. So when it comes to patterns of like, how long it takes between eruptions or how long until the next one, that's a little trickier, right? Now, the patterns that we like to rely on more are, number one, eruptions usually go through a summit sequence and then some kind of flank sequence, right? So, for example, 75 would have been a summit sequence, and then 84 would have been a flank sequence as far as eruptions. They often kind of are paired in that fashion, and in that case, it took 9 years between them. Sometimes it can be not nearly that long between them, a year or less kind of thing, right? That's kind of one pattern that we often see. Another pattern that you see is that even within an eruption, that second phase, like 84 eruption, that eruption begins at the summit also, and then works its way down to the flank within itself as well, right? So that's the second pattern that seems fairly reliable, right? And of course, you're looking for all these signals of earthquakes and tilt and deformation elsewhere. So if it happens to bypass, you can still catch it, right? So you wouldn't be surprised in that case, hopefully as well. The third thing is there are patterns of alternation of eruptions between a southwest rift and a northeast rift. Now, people who have used those in the past have gotten burned because sometimes it'll go southwest, 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 and then go northeast, northeast, southwest, northeast. So that's a little less reliable. But because the last eruption occurred in Mauna Loa's northeast rift zone, we would lean towards the next one being on a southwest rift zone. Not to say this has to be that way, right? Actually, first on a summit, And then the pair that goes with that next one being on a southwest rift zone. So there's quite a lot that we can anticipate now. I mean, I'll just stop it at that, because when Frank gives a talk later that we're going to replay, he's going to talk about a lot of stuff in way more detail, and I really can't, do the same job as he can, right? He was just awarded the Meritorious Service Award, so for his long career in Mauna Loa, so he's the real expert there. So we'll listen to him talk about these patterns and the rates and all that, and how we can talk about preparedness, right? Because really, if this earthquake sequence was still going from 2 days ago when it was escalating now, and we're talking about, okay, something's going to happen at the summit, we're getting a little bit too late for preparedness already, if that's the case, right? Something's already happening, and it's less time to talk about getting prepared, and more so, but we'll be talking more so about what's going on. So the fact that this thing did a little pump fake, had a go, and then it stopped, and it's giving us a little break right here. We're going to take this chance and go back to preparedness, because it's a great opportunity. And really, Mauna Loa has been doing nothing the whole rest of the year. We've been waiting for it to do something to talk about preparedness in Mauna Loa, and here is the first thing it's done all year, actually. So she's alive.
Yeah, she's still out there.
She's coming someday.
Derek just asked, can Mauna Loa have a flank eruption without a summit eruption first?
There have been eruptions that spent very, very little time at the summit.
Right.
Very, very little time, like hours.
Just popped out.
Yeah. So, and that's, practically speaking, it's down on the flank in the opening sequence, we'll call it.
Right.
Right. So there are times that does happen, right? So, all those patterns can break that just went through, which is why most reliable is earthquakes and ground tilt and GPS and INSAR, right? Those right. Gas emissions as well, right? We can even measure SO2 emissions by satellite now if that thing were to put out a big puff.
If you want to surprise people on Mauna Loa, or at least the experts, in a sequence that might be like, oh wow, what's going on here? It'd have to be one of those radial eruptions, which are rare, but we know they happen. Last one happened in, 1859? Mm-hmm. Rather decent sized eruption, but that we haven't seen that in modern times or in documented era, really. So we don't have that much to go on exactly what that sequence would look like. So that one, might end up being more debated. Like, is this a radial or not? Until it pops up, it's like, oh yeah, it's a radial. Yeah. I'm just trying to envision what that sequence might even look like.
Right, and the monitoring data, right? Yeah.
Right. And would we even have the right instruments in the right locations for it to catch it right, type things? Or do we just miss the net with one of those weird radial eruptions where it erupts not in the rift zone, not at the summit, but on the side, probably the northwest side of Mauna Loa, somewhere downslope? And those are the real weird ones.
Yeah, it could happen. Yeah, I mean, we can rely on earthquakes quite a bit, and earthquakes have been around for a while. So I mean, even in '75 and 1984, before there was GPS, they had earthquakes, and even before the seismometers were as sensitive, and they were even before they were as accurate, they could still know, oh, there's a lot of something going on somewhere over there, and that would give them some clue right now as far as how much, how big, how long. Any of those things would have been much harder to answer, because you only have one data set, the seismicity. Right. But you do have something to go on. When the offshore volcano, formerly known as Loihi Kamaʻehuakanaloa, erupts, we also can see its earthquakes from land, even though we are only off completely to one side of it, and we're looking just kind of totally in profile at it, right? Mauna Loa, even though the density is not sparse on the volcano, there are stations on Kohala, and there are stations on Maui even, right, that we kind of can surround it and locate it a little bit more precisely. So I'm not as worried if there were to be a radial eruption that we wouldn't catch it.
Right.
It would just look weird.
It would look weird. It would probably cause a lot of debate online, would be my guess. Yeah. Is it happening or is it not? All that kind of stuff. Especially it comes up when one of the areas that we see earthquakes already, like up near the summit on that northwest side. Say it does it about like a quarter mile from there. Could get weird, but we'll play that by ear right now. We just have a little maybe intrusion. Mm-hmm. But yeah, I think that does it for the first round of questions. We will be doing one more after we get through Kilauea. All right. And I'll try and answer what I can in the chat as well.
Sounds great. Thanks, Dane. So let me.
Oh, we also had Susan L dropped an $50 super chat with no comment but a little emote. Appreciate that support.
Mahalo, you guys, for your support. We really appreciate it. All right. So turning to Kilauea. Kilauea, here is our weekly rainbow on Kilauea. And Dane pulled out from the KW camera here. Lots of steam adding to the gas. Likely a rainstorm coming through and hitting that hot crater floor, right? Even if it's crusted over, there's all that magma / lava underneath there, heating it up. So that's our opening view here today. But let's step through our time lapses, starting with that KW camera on that west rim of Kilauea there. And get this line up here. What you see mostly is activity in that persistent summit lava lake. Right in here. You see some ooze-up flows coming up around the perimeter. Right, there are some that occur. Let's wait for them to occur. See a low level activity here in the north, but there is a big one on that northeast part of the dial. Some occurring down here in the southwest. Here's one in the northwest. I think I spotted one over here in the east, but basically it's the same as we've been seeing for the last few months. Right, that same pattern, steady pattern, is still happening. So looking in at the thermal, let's zoom in a little here to our thermal. We see a little bit of those ooze-up flows up here in the perimeter. On the left, here's one in the upper right, upper left again, and one in the lower right. So all this stuff is getting wider than our camera here, so we're missing the bulk of the action, but we can see it leaking onto the frame here. So zooming into the lake itself, we've often looked at this back wall, at this coloration, the thickness of it, as an indication of variation in the lava level at the summit lava lake here. And if you keep your eye on that, it's actually remarkably steady. It's barely changed, as we can tell, within the resolution that we have our time lapse running here. And it could be going up and down at a smaller time interval than we're using the frames, basically is what I'm saying. You still see that southeast pit still active, right? The lava is going underneath this little isthmus through a little tunnel right there and feeding below, and so the surface continues to overturn as there's additional heat being fed into that big pool below there. It's able to form a skin on its surface exposed to the air and then recycle that skin and replace it with lava over and over and over again. That's why you see it kind of getting brighter and dimmer and brighter and dimmer over here. And we have against this eastern wall that spattering zone where the lava is sinking back under and going back down right there. The gas is bubbling up and forming that spatter zone right there. And you often see one over here where the lava is going underneath this little tunnel as well, right? And likewise here in the northeast, but not as visible in this sequence this past week. So that's our thermal image. We'll switch over to the V1 zoomed in visual image here. So similar point of view. Here's our entry point into the lava lake and circulation coming across. Our spatter zone in the east, there's a northeast one, and here's our pit that's overturning in its surface. So it really hasn't really fluctuated a whole lot. It's been steady in there. What's interesting is that you now have all these features, like these spatter features that surround there and over here as well, and you're starting to form terraces out of these things, right? So it seems like you can see some lines of cracks occurring right over here as well. A line of crack there and there, right? So that's the edge of this piston head, as I've been describing it, where the lava is filling underneath here for the most part and lifting this whole thing up. So you're getting deformation of this whole area, and the ground is lifting, and the lava is still inset within it. And depending on the rate of whether this ground is lifting at the same rate as the lava that it's hosting, or if it's able to go a little further and the lava kind of settles back down at a lower level, that's what can allow you to form these terraces, these kind of terrace benches here on the edge of the lava lake, which is something you can see when you're looking through telescopes at the overlooks up there. So that's our V1. Really not a whole lot of variation. We'll keep moving. And we have our S1 camera back, and it's been up for all week. So we have a 1 week time lapse of our S1 camera. A slightly reverse angle. Here's our west vent over here. That southeast pit is over here. Northeast and east over here. We're catching a little bit of this ooze-up on the edge of the frame. And really, if I zoom it in, it's more obvious, this kind of flashing pattern of the overturning of the crust of that the lava in that pit right in here. Otherwise, not a whole lot I can point out for you guys today. Just good to see this view back, and you can see from this other angle these set of cracks I'm talking about. I go through here, and there's another one coming through down here as well. Okay, that's the S1, and finally the last angle, the reverse angle from the east looking west. So our lava lake is all the way at the far end, distant over here. We see ooze-ups run a perimeter off to the right, but also coming up right down here in the bottom right of our screen in the foreground too. So that's part of that same process. Lava leaking up around that central piston that's all cracked up and oozing up and filling that trough. Kind of pushes and tilts and affects this whole surrounding moat area as that middle part's being pushed or pistoned upwards through the center there. It's really fascinating stuff. This is actually part of discussion in this week's Volcano Watch, so we'll get to that here in a little bit. But for the moment, we will move on from what we see in these time lapses and a summary of the activity over the last week to the hazards, which are mostly the gas. You can really see all the gas coming up all the time. It's not what we often focus on, but it is there essentially all the time. So here is the VOG forecast from the VOG mapping project. Let's make it say hazard up there. All right. Hazards. What you might see is that, so today we'll do a little bit more in depth. We're looking at SO2 first. Here's our source Kilauea event, and you can see that the SO2 is spreading not just to the southwest, but also around into the saddle region. And when it does that and comes around this northeast flank of Mauna Loa, it often gets Volcano Village and a national park as well. So turns out today is not a great day for VOG in a national park. But to dig into it a little bit further beyond just the park here, because there are other parts of the island as well. We don't always do this, but if you click up here, besides an SO2, SO2 is the gas part of the cocktail, but click on SO4, and that's your sulfate aerosols. So further from the vent, as these SO2 flies through, you can see it can accumulate VOG in other areas that are not having that direct gas emission. So for example, over here on the Kona side, you can see these orange and yellow flashes pop up right here. Some of these periods during the week where the VOG is really bad over there, despite not having as much emission, mostly because of the weather patterns keeping that material trapped in the atmosphere over here. So back to our SO2 and SO4. So that's the overall pattern. It's kind of swirling. Hilo is still in the clear, but really the central part and western part of the island has been affected by these swirls of gas. Here is our purple air citizen monitoring site, right? People, you can get a purple air monitor and connect it to their network, and your data will show up on this map online as well too. So you can see the areas in Kona, for example. You can click on a station like that. That's currently a 0, but you can see its history and see that it actually went into this yellow range earlier today, this morning. Right? And of course, depending on where you are, there could be other pollution sources if you have some industry nearby or something like that. It's most reliable here in South Kona, right, where we have the wind often blows across. You can see that they've been getting VOG into the yellow EPA range here. Ocean View. You can see regularly, almost on a daily basis, if multiple times a day, it's peeking into that yellow zone. Let's go to Pahala. Pahala stayed in the green, but you can see it's got variations as well. And I'm going to go all the way up here to the national park. And you actually can see there in a national park that we are coming into the yellow. So let's look at this more closely on the park website. Here, I'm going to give it a refresh. Here's the national park website. And it is showing winds of 4 miles an hour, right? That's hardly anything. That's why instead of showing what we typically see as this trail of gas blowing away, it's showing it. It's all hanging out in here because it's not really blowing enough to carry it away, right? So everything currently is in the green here on our map. And if I scroll it down here, you can see the history of sites today. Right now, we're actually in, it shows yellow at somewhere, right? Maybe not one of those sites, yellow, and then not long ago, orange, reds, a little bit of green. Red is unhealthy for everyone. Orange is unhealthy for sensitive groups. Yellow, moderate, and green, good. Right? So what it's actually showing is SO2 good, particulate matter moderate. So let's click on by site to get more detail here. And you can see the visitor center. So this column over here on the left is SO2 for the most part, and this one's particulate matter for the most part. Visitor center got both SO2 and aerosols this morning. The parking lot got some SO2 as well. Not as much of the aerosol. The campground, Namakani Paio campground, this morning catching some of the orange SO2. Kahuku is all green. It's usually where we see it on Ocean View, but the vlog is not making it there as concentrated this week. Steam vents in a national park this morning. The SO2 coming into the orange. Other places, Devastation Trail, the Uekahuna area, everywhere else is in the green, right? So it's very, very localized, and even when it does hit a place, you can see it's each of these bars is about 15 minutes. So even when it hits a place, it's usually not there for more than an hour or so. But it is around, especially today. And so be aware of that as a possible nuisance if you're trying to visit a national park. Okay, so speaking of the national park, we'll turn to our lava viewing update now. Lava viewing report. Here's a park map of their identified viewing areas. Uekahuna up here in the north. Devastation Trail here in the south. And today we'll feature Kupina Ipali over here in the east, just south of the visitor center, not far away. Really not crowded, plenty of parking, great place to go. It still shocks me how empty this is compared to Kanakakoi, where the parking lot's getting full. I was there the other day and the parking lot got full at 5:45 p.m. Of course, from that point on, you get a couple cars coming and going, and spaces do open up, but you can see that the bulk of it's full by that point in time, right? Sunset at 7, so that's pretty high demand for an area over there. Over here, Park at the Visitor Center, quarter-mile walk, all paved and great views, so that's what we'll look at here today. I have for you guys a compilation of, this is a video that I shot on the evening of August 2nd. You can see that view from that poly, and I've sped it up here so you can see the transition from day to night and the changing light and the circulation of lava, right, from this right to left, the west vent glowing and fuming up here in the upper right of the image, and the spattering sources. This is basically into that southeast pit over here through that little tunnel that's buried. And you can't quite see any other spatter activity in this particular frame right here. Although, and not too long, we'll see this northeast pit will actually open up as well and start spattering some more too. The lava is circulating under there. It's just a matter of how much gas is getting dragged down. And if a big enough bubble accumulates, then it'll burst back up and open it back up like you just saw happen right here. So this was the evening of, what was this? Tuesday night. And I'll zoom in a little bit so you can see what in real time, right, normal speed, some of the spattering would look like. So if you're looking through a telescope or something like that, show you what it would look like with that evening light here for you guys. So now you can see a little bit of that eastern spatter spot just once in a while peek up above it. Otherwise, here's our southeast spatter spot. There's another one over here further in that, kind of in the south, right? All right, your nighttime view. Same thing, but you see how now you see more of this glow through the crust of a lava lake. The seams between the plates and the crust are brighter, and when those plates are a little bit thinner, sometimes you actually see the lava glowing through them as well. Okay, so a few hours later, the next morning, here comes Two Pineapples on YouTube, and here is their contribution. Mahalo, you guys, for sharing once again. Check them out on YouTube, Two Pineapples. They're streaming just about every week. We'll post their schedule up there. And likewise, they're showing you guys views of the spatter, of that west vent. But note that the following morning, there's a big new lava flow breaking out behind the lava lake up here. And it's got a very, very slow movement over here to the east. Not as fast as you see in the lava lake itself, but definitely pumping out there, right? So it just goes to show how even a few hours apart, you can get a whole bunch of different activity. So here's their zoom in, nighttime, daytime. You get a little sample of all the different views you can get. And consider this just a little trailer. Really, you got to go on and see their multi-hour stream to appreciate all the different details of the landscape there, right? And one final parting view here, the wider view of the lava filling that pit, fuming after daybreak. Mahalo once again, you guys. That's the lava viewing report for the week. Just be aware, as always, check Hawaiʻi Volcanoes National Park website. They will list all kinds of closures on here. Like, for example, Lava Tube is closed, Kīlauea Overlook is closed, Puhimau Crater and Parking Lot are closed, Hilo Pali Overlook is closed, for example. You can look at all the rest of that. But they also have links to current conditions with the webcam. They have the map I just showed you guys with the numbers labeled. Each one of those numbers has pictures of daytime, nighttime views, where to park, how long you gotta walk, what you might see, whether there's restrooms available, how much parking there is. 1, 2, 3, right? So park website's really great on this viewing orientation at this point in time, so check them out. I did mention something just there that I'll include right here. Nahuku Lava Tube has been closed for structural monitoring and safety. Also on Tuesday that occurred, or actually Monday, I would say. Or I guess Sunday, they say here, actually. So, start over. Sunday, they closed the lava tube, and that occurred after the park geomorphologist alerted park management that the crack meter installed on the ceiling of the lava tube had moved by almost 2 millimeters Saturday night over the course of several hours, and then by another 0.5 millimeter by Monday morning. So altogether, 2.5 millimeters between Saturday and Monday. And if you're having a block on a ceiling, and the block has got cracks on all sides, or it's loose in some way, and you see on one side the crack is getting skinnier, then possibly on the other side the crack is getting bigger, and you might worry that that whole chunk might fall off. So they're going to keep monitoring those crack meters. They say that while the movement is slow and not accelerating, that these movements of a large rock slab are unusual in a monitoring record. And a return to movement similar to the previous record would need to occur before the lava tube would be considered safe to reopen. And it's not clear how long that will take, therefore indefinitely, right? Prior to the changes this past weekend, there was only less than 1 millimeter of movement since November 2019 when those things were installed, right? So it really is a recent movement, and it hasn't happened ever since it's been installed. So that said, bring in Dane here. What you got, Dane?
I was gonna say, is that the? I remember we took the tour when they reopened Nahuku, and we were looking at those monitoring instruments. And there was one rock that was in particular that they were concerned about, and it almost looks like it's that same rock, but I'm not sure. I don't have any record of that rock. I mean, I guess we recorded it, but I'd have to go look through the video files to find out which rock it was. But
yeah, well, we know it was one that they were worried enough about to install 2 different crack meters on. So likely that's the one. Yeah.
Yeah. Okay.
So the restrooms remain open, the parking lot remains open, but unfortunately that lava tube is closed until further notice. So as you plan your trip to the park to see the lava, unfortunately that is not an option at the moment. There are lava tubes around on the island, so that's something we can maybe cover some different day, but you have to look at your other options there, essentially. All right. Anything else? Anything else on this thing before I move on?
Nope, I think that's it. Hopefully it'll be open, sooner than later, but we'll never know on this type of thing.
Yeah, just wait and see. All right, so let me transition us over to the media of the week.
I will say though, before we go, hiking that scaffolding down there, I would not be happy about. That into the lava tube, send it all up.
Yeah, that would be a challenge. Let's see, where's the lava tube picture? There it is again with the scaffolding once again. Yeah, yep. Yeah, well, they've done a lot more than that. They've hiked bags of concrete in there, all kinds of stuff. So they've had to do all kinds of work over the years. That's just how it goes. Right. And really, much of the park is like that. When you're trying to fix fencing on some upper slope of Mauna Loa or what have you, there's quite a lot of this hiking things in and out, and yeah, a bunch of warriors up there in the national park keeping that thing maintained.
And you don't want to lean like a 20-foot extension ladder against that rock wall or that the lava tube exactly. So good idea to drag out the scaffolding.
Yeah. All right, so let's go on to our media of the week, which is here. So this first batch was released July 29th, actually August 1st, and it's of July 29th. And these are images of the summit eruption. So here is zoomed in on the west vent. You can see the spatter cones fuming quite a bit here. There's a couple of spots of glow visible down in here. But you see these kind of craggy peaks, the remains of this constantly evolving landscape here. Here's another view. This is looking at the main lava lake surface and that now separate southeast pit. It's pretty striking how wide this distance right here has gotten, right? Between the actual pit and the main lake. I mean, we saw that be pretty skinny before and collapse in, and interesting to me to note how that has changed right there. Otherwise, you see this daytime view of the active lava. It looks more silvery than red. If it's really bright, bubbling in some piece of it, you might see a little bit of red show up there. Otherwise, the better way to tell, you can see here there's some older chunks of crust that are actually solid. That's like these things that are floating on this newer silvery stuff, right? Which is also forming a skin that's getting rumpled up here to form these pahoi-hoi-like coils. And that's what you can see here, and obviously red lava at the entry point to the lake. And finally here, wider angle view, you can see the Wikahuna area up here in the upper cliff. You can see the whole crusted over lava surface is all of that. Going on to there, going to there. That. You can see when we talk about how far is it got to go to reach that next down drop block and spill over, we're talking about this little distance right here. Right, it's got to come up basically up that. And you also, by zooming out, can see where the scientists are standing on the remains of this crater rim drive, which you can see the pieces fallen into the crater. So here's the actual edge of the ground immediately in front, or maybe it's more like this, right? And then there's another edge down here. If I scroll or zoom it into way over here on this side, where'd it go? Way over here on this side, there is that farther lower piece of that road right there, with a bit of a center line draped over right over here on the edge too. So those are our volcanic views of our media this past week. We do have more than just that. We have views of the AEM, the Airborne Electromagnetic and Magnetic Survey over Kaluapele, Kilauea caldera, that occurred on July 28th. So there is a view from the south from Kanakakoi, Mauna Loa, and a helicopter right here in the foreground. Let me get that a little more zoomed in for you guys. There. See what that looks like. Try to get it all on the screen here. Oh, there it is. Floating over the summit crater. Different view, different angle. There it is, kind of hard to see that. I'll zoom that one in a bit. There's that ring that's being pulled around, slung below the helicopter. Right. And we can look at some of these captions to remind you guys of what's going on here. It's a 40-foot horizontal loop. The helicopter's flying 120 to 175 feet above the ground in a grid-like pattern, and the loop is suspended 35 feet below it. By doing this, they can passively detect variations in the Earth's magnetic field, which allows scientists to image the shallow structure, faults, and groundwater pathways beneath the surface down to about 2,000 feet or so. All right, here's another view here, looking in. Let's get that one zoomed in on telephoto as well. Let's see. There is the helicopter itself, and the ring down in here. I can see if I can blow it up without losing my spot. There. You can see that crater is so big when a helicopter's flying through there. It's amazing how small it can look. It's getting lost in the image if I zoom it all the way out. Right, so come back here. And another telephoto view, this one looking more directly over the lava lake. So let's look at that one. There is that active lava surface in the background. It's hard to tell from this angle whether they're actually flying directly over that hardened lava lake surface, or if there's somewhere here in the foreground and we're just looking at that behind them as part of the background. Not quite clear on that, but still great to see it juxtaposed from this point of view regardless. And one final one, zoomed in a little bit more as well. There it is. So the survey over the caldera has occurred. And there is one final piece of media to share this week, and this is an update to the video from the USGS. We're now looking at the B1 camera from March to August, and looking at the crust being lifted by lava that's injected below there. That's what they call, quote, an endogenous process. So besides being lifted up like that piston head, lava is also leaking out the sides and paving the bottom there. So they're actually gonna this plays pretty fast, and it loops a bunch of times, 6 or 7 times. So let's see what it looks like here. And once again, this is a B1 camera looking from the east. And you can see occasional in the foreground changes in a texture where it gets all one big flat area. That's the ooze-up flows kind of flashing day by day, but you really can see the growth of these hornitos on the main crust here, and how they spread outwards. Right, it's fascinating. Look at this one right here. It starts off down here, and it ends up here. Pull that back one more time. So that's what we're talking about when we're talking about the lava injecting under the crust and lifting it up, and you can see the cracking occurs. And it's really the central area right in here. That's the core of it. Right? Oh, pretty cool to see that once again. So this is actually the discussion of this week's Volcano Watch, and that's what we'll talk about next. Is we'll switch our label on here, and we'll use this as our segue to our Volcano Watch this week, which is Kilauea Summit Lava Lake continues to be quietly remarkable. So this week it's kind of a status summary of Kilauea, so I thought this would fit in at this point of our update today. So the eruption hasn't made the news recently, but that doesn't mean that the activity hasn't been noteworthy. It's just operating quietly in the background without much fanfare. Here is a recent picture of the lava lake, and they talk about deserving more attention here. So this is going to be detailed in the article. I'm not going to read the entire thing. You guys can go and look on hawaiitracker.com for that, but I'll summarize it here for you guys. So the first thing that they're talking about is the pattern of collapsing and refilling. So we do happen to be witnessing that, right? We saw a huge collapse just 4 years ago, and now we're seeing it all the way refilled. Right? In fact, the very last collapse of the summit caldera was it August 2nd, 2018? So just not exactly 4 years, very, very close to 4 years ago today. And really in that time, we've seen the magma filling underground for the first year and a half or so, and then popping up and now filling that upper crater as well. So point one, filling and collapse cycle is something that we're in the middle of seeing, and we're really lucky to be able to see it this dramatically in this short a time. So it's similar to what occurred in the 1800s and 1900s. But we didn't have the same webcams and monitoring data and all that stuff, right? So in that sense, watching the current activity is like having a time machine to an earlier century on Kilauea, as USGS says right here. So they mentioned some other things. The collapse of the crater in 2018 was one of the largest events in the last 200 years. So obviously the ones before that were also comparable. Since returning to Halimamau in December 2020, lava has refilled about 17% of the volume of the 2018 collapse. So that's right on with the same number we've been telling you guys from our calculations as well. It's all consistent, which is great. So the next point you're talking about is just the manner in which lava is refilling the crater. So rather than just kind of pouring in from above and leaving layers that are just filling a hole, right? You could have like a crater and lava coming in and filling it layer. Instead, it's coming in and it's filling below, and that crust is rising from below, right? That's kind of what you're seeing there. And that's what we just saw on that webcam, right? So laser rangefinder, the endogenous growth, they also term that, quote, bodily uplift, noting it was observed in the 1800s and early 1900s, but it hasn't been observed so much in the past 100 years. And certainly hasn't been caught by the modern instrumentation. So that is the long and short of it here. USGS once again highlighting what's happening at the summit lava lake, and consistent with what we've been recapping for you guys for the last few months as well. So that is the volcano watch, and from there we'll go into more of the details of what's actually going on with the monitoring. So let's transition to monitoring before we take a little break here. And looking at monitoring, here is the summit lava depth for the last week. So the range here starts at 366 at the left edge, and it ends over here at the right edge at 367.5, 368-ish, somewhere in there. Peaked at 368.5. So we're talking about a 3 meter or 2.5 meter gain over the last week or so. So it's not a huge amount. And if you look at this plot, there's lots of wiggles on here, right? But there's no huge variation. There's like, there's a slight half-meter variation down, and another slight half-meter variation down, or slight half-meter variation down, and one ongoing now as well. And overall, the pattern is mostly up. The summit tilt that corresponds to that, you can see a larger deflation-inflation cycle that's ending here, and then a new one comes in actually small and short, almost like a mini one in there, a small one again here, and given the way it's shallowing out, maybe another small one coming in here once again too. So if I zoom it out to the last month, you can really compare. So here's a lava depth for the last month. Here's this last week I've been talking about, that's fairly steady rise with really minor variations compared to the variations we're seeing earlier in a month, right, where it was really dropping up and down as much as 6-8 meters or so, right? And we're not really seeing that level anymore. And looking at the tilt, we're following the same pattern as that. Really, the pattern of deflation-inflation cycles we saw last month was large cycles that lasted for several days and were pretty deep. So here's the last couple of those showing up in the graph there and there. And then we had this strange return with its 3-step phase. And then last week's update, we talked about how the cycles had actually decreased in length and depth. And so here they are. right? That kind of middle phase. And really, in comparison to that, the ones we have this week are even smaller and even shorter than the ones we had last week. So it's a 3-stage pattern here, which is fascinating to note. And we'll see what happens next. SO2, because of this lesser variation, right? We're not varying up and down nearly as much, so we also don't have as many data points, but really we expect the gas levels to be a little steadier here in this between 1,500 and 2,000 tons per day range that's been typical over the last month. So that is the monitoring pattern and the big picture showing what we saw in that USGS time lapse with the whole crust of the crater floor rising. Here's that long-term pattern rising higher and higher and higher and higher and higher. And superimposed on top of that, then you have these little variations of lava levels within the pit or localized movement on the crust here or there. But really the long-term pattern, big picture, is it's still rising. That's the bottom line. Final thing in our monitoring is a GPS. So coming to the GPS here, looking across Kilauea summit, north to south, we are getting still that extra scatter at the right end of our plot over here. And you could argue that we've gotten a little bit steeper than we were before. But that's hard to tell with much confidence because of the scatter that exists right in here, right? So you can see that really over the last year, it was extending, but not as fast a rate, even with the variations in scatter. And then it was extending faster. And the question is, have we hit like a third gear, so to speak? It is looking that way a bit, but it will take more data to overcome the ambiguity of the scatter here. So that's the summit caldera. On the east rift at Pu'u'o, you see the opposite trend. It's still going down, which means it's contracting, coming together, deflating, exhaling. Like there's really nothing building up in the east rift zone at this point in time. And the rift zone has many sections, but we're just going to lump it all as one thing right now because there's really nothing noteworthy anywhere along there. So that means no change in threat or hazard level or anything like that. Everything is still good and still a great time for lava viewing. That's really the bottom line on Kilauea. Bottom line on Mauna Loa still is be prepared. We'll take a little break. We'll talk about some community events. Look quickly back at what's happening at the end of the 2018 eruption, and then we'll show you guys a Mauna Loa presentation about 20 minutes long from Frank Trusdell coming up here. That will help us with this preparedness point, if that's something that you would like more information about. So,
all right. Well, let's do some thank yous before we get into the second Q&A, yeah?
Yeah,
we do have a
great.
$10 super chat from JW, who says, enjoy the lectures, and Dane hosting was cool. Hope to see that again. We will have, always mixing up the formula, and especially when something starts happening, then who knows what we'll be doing exactly, who will be hosting, and how it goes down, but we'll figure it out as always. I appreciate the support there. We also want to shout out our longtime supporter, Kilauea's Bar and Grill, 2 locations, one in Pahoa, one in Orchid Land. That Orchid Land one is the new hotness. They got concerts there with the Kaika Marzo and all the guys down from Kalapana that used to play. And they do that live Thursday nights. You're going to need a reservation for that one because that place is packed for the concert. Great food, reasonable prices. Definitely recommend them, and we appreciate their longtime support. And with that, I think we can start with a few questions here. Pull them up. I'm getting a little feedback. Sorry.
I'm just flipping through some of our current webcams here to see if there's anything different, but everything's looking just like it did before, or now.
And we have a $4.99 super chat from Dude. It says try again. Or emo that says try again. Appreciate it. Appreciate the support. I'm not seeing any questions. Anybody got any questions? We'll pause for a second and keep going through the chat, but I don't see anything that we didn't already hit on. Let me check the different. If anybody does have a question, yeah, go ahead.
Just take that as a sign that we covered everything so well that there are no questions. Either that or I confuse everyone so much that I don't even know what to ask.
Eyes glazed over.
One of the two.
All right. Well, we do have something, we've been saving this one for a little while. Mr. Mauna Loa himself, Frank Trusdell. We figured we might as well wait until there was something to talk about on Mauna Loa. So now is as good a time as any to go through Frank's speech here from Volcano Awareness Month and try and, figure out anything that maybe anybody's missing. If anybody's new to the island, definitely check out this guy when he speaks. I mean, he is the authority on Mauna Loa. He's not known as Mr. Mauna Loa for no reason. So, yeah, excited to go through that one with you guys, and we'll be in chat. If you have any questions, we will be able to clarify those at the end.
All right, mahalo, Dane. So let me switch things over here. I just want to also make sure we mahalo. Oh, this didn't come up like I thought, but we're going to mahalo the USGS as usual for all the information that we're using. This is all their information, their updates that we're rephrasing, combining to present to you guys in this kind of format. Right? Since there's so much out there, it's easy to miss things, and that's one of the services we're offering to you guys here is synthesizing, compiling, and interpreting a little bit as well. So mahalo USGS as well. All right, with that said, let's turn to our community corner as our first item of business here, just so we can address some of the scheduling issues here. So let's first thing to mention is the AEM survey that we've been talking about and showed you guys pictures of just now. So let's see what this most current refresh gives us. But what I've seen for a while now, and I'll scroll down to show you guys. Here is our timeline. The last reported dates for flights were July 29th, going through FLT 12 here. So nothing's been posted since then. And we have seen no record or mention anywhere of flights in August yet. So we're going to look for some clarity on that. But at the moment, it does not appear that there are ongoing flights. And if there are, we'll try to share any announcement that's forthcoming about that as well. Maybe there's some rescheduling happening or some technical issues or something like that. We'll just keep it going. It does say here at the very top that this is still an active status page, right? So perhaps we'll see something pop up here below this July date and something in August, and then we can share more with you guys about what's happening with flights. And I've been holding on to that video on Facebook just until that's announced, so you guys can see it right before it actually happens. But we'll see when it actually happens. That's the first point of note. Second point of note is that the Revitalize Puna meeting that occurred 2 weeks ago on July 12th, more 3 weeks ago on July 12th, has been released by the county. And that's an hour and a half, and it's updates from all the county departments about issues in Puna, recovery issues, other issues as well. So Dane can drop that link in the chat if anyone has been looking for that from the county. I'll just mention it exists here, and I won't do anything beyond that because that's an event we saw many of you in person already. They're local, and those of you who are not around and want to see what's going on, check this out. Revitalize Puna. Okay. Next item of business in our community corner here is still on the calendar is August 13th, Saturday, August 13th, 1 to 3 p.m., Ocean View Community Center, Hawaiʻi Volcanoes National Park, meeting on public access to the recently acquired Pohui coastal area. So check that out. There'll be other meetings besides that first one, but that's the first one announced. Saturday, August 13th, 1 to 3 p.m. is coming up. And one other meeting that we're going to share with you guys here and talk more about is August 18th, 2022, 3 to 5 p.m. Pahoa Community Center, the Pohoiki Boat Ramp. Presentation and discussion of the pre-design report. So
don't expect good news on that one. That's all I'm going to say. Don't expect the good news.
Yeah, there have been some challenges we hear, and those challenges will have to be addressed, right? And we will address them, but they do have to be addressed. So that's where that stands, and more details upcoming. And that is all I have on the calendar here, actually. So the next thing, pause. Next thing is just a quick revisiting of what was happening in 2018, the very end stages of the sequence in 2018. So here you see lava inside Ahu'aila'au Fissure 8, just puddling up, not actually flowing into the channel as occurred, and then lava withdrawing, forming a small little crater pit, and then about a month later, popping back into that pit and refilling the pit, spattering a bit as it was caught in this drone footage here, before finally that being the end of that. More importantly, those final stages of eruption, lava was draining out through the channel, as visible here in this last stage of the sequence. And coming around towards Pohuiki, we were quite worried about the lava still draining out of the channel and affecting the boat ramp. In the end, it didn't, but it was the actual erosion of that lava, all the sand, that didn't ultimately, over the following several months, get pushed in by the current and block off the harbor. And that's really what we're talking about in this area, is how to restore access for the fishermen and the swimmers in an area that doesn't have any other ocean access for a ridiculously far distance. Right, so we don't want to keep hammering 2018 every week, every year, talk about it, but this end sequence is one that I celebrate more than the others, I'll say, and so I just wanted to make a note of it here as well.
I'll just say one thing about it too, is that it's a good thing it stopped when it did, because in that last surge that came through that system, it created an absolute train wreck in the lava channel in the lower segment before just above Green Mountain. And basically it completely compromised that lava channel. If another surge came down there, it would have looked a lot different. It would have diverted from that channel and started going every which way type of thing, making new ways down to the ocean. Like, it's a good thing it stopped when it did. One more could have been, more houses lost immediately type of thing.
Yeah, because it was all about the intervals, right? The intervals early on were so short that, really, like, between one event and the next event, everything is still fluid and flowing. But towards the end, intervals were getting longer and longer and longer. Then the lava started to have time to stall in the channel, and then you start having it pile up. And that very last one, we thought, okay, if this is actually going to be an interval, which means another one is coming, it would have been the longest one, and it would have been all kinds of trouble because everything had collapsed and was blocked. The channel was blocked by that point in time. So we're thankful. Ultimately, this is the week of being thankful, of commemorating thankfulness. 4 years on, and I just wanted to make sure we touch that base before we move on to Frank's presentation here. So with that said, let's switch over here to his presentation. Let me get things lined up here and make it a little prettier for you guys. And this, just to remind you guys, was presented at Volcano Awareness Month in January of this year, and we've been holding on to it since then. And as this opening title says here, Mauna Loa, are you ready for the next eruption? By Frank Trusdell, geologist. Mauna Loa is an active volcano, although it's been quiet for almost 30 years. An eruption is not imminent, but patterns of ground formation in Mauna Loa over the past year, call it year and a half now, may indicate that new, previously unobserved processes may have occurred. Mauna Loa lava flows have the capacity to disrupt lives and commerce throughout the island of Hawaii. What resources are available to help you prepare for the next eruption in Mauna Loa? Join USGS HVO geologist Frank Trusdell, who studied Mauna Loa for 2 decades, as he presents his talk about Earth's largest volcano. All right, so I will let Frank take it away.
Welcome to a talk about Mauna Loa, and are you ready for the next eruption? My name is Frank Trusdell. I work at the U.S. Geological Survey's Hawaiian Volcano Observatory. What can you do if you live on or near Mauna Loa with respect to hazards. A few simple steps that you can take is to learn about the volcanic hazards that could affect where you live and your community. And this talk will focus on helping you understand lava flow hazards. Other things you can do is to develop a plan with your family. And the third thing you can do to stay involved in and notified of potential volcanic hazards is to sign up for emergency notifications. For Mauna Loa, all eruptions in the historical period have started with a summit phase. This is important. If Mauna Loa is going to erupt, and eventually, if the flanks of the volcano are going to be inundated with lava from the rift zones, there's going to be a summit phase first. That should be everyone's alert that the volcano potentially can come to your neighborhoods. Where can you get information? You can sign up at the USGS for Volcano Notification Service using the URL. If there's any change in the status of the volcanoes in Hawaii, on Hawaii Island, we will send out notifications. As an alternative, you can sign up for county CD alerts. Now, the CD alerts would include volcano notifications, fire, road closures, etc. The important thing to know about lava flow hazards on Mauna Loa is where you live affects the amount of time that you have to respond to an eruption. As I stated before, this talk will specifically focus on lava flow hazards from Mauna Loa. There are other kinds of hazards that can affect you, such as earthquakes and bog and ground cracking, but this talk will focus on lava flows. In order to understand lava flow dynamics on the island, it's important to know where the source of the flows potentially are. In blue are fissures that represent lava flows from the summit of Mauna Loa in the caldera region. To the north and east are shown in red fissure vents from the northeast rift zone, and they trend in the general direction of Kilauea, and geographically this area here is from Mountain View to Glenwood. On the south side of the island is the southwest rift zone. It extends from the summit caldera down the flank of the volcano all the way out to Kilauea or South Point. And to the north and west are these dark brick red lines that represent radial vent fissures. And these fissures erupt on the north and west side of Mokuaweoweo from beneath the ocean in the submarine environment all the way up to the summit of the volcano. Historically, there have been 33 eruptions from Mauna Loa. Approximately half of the eruptions erupt within the summit of the volcano, the caldera, and the flanking regions up high. And fissure eruptions have broken across the caldera, and lava flows that have been created from these eruptions have gone 10 to 15 kilometers away from the source. So in reality, these lava flows have not posed a threat to communities living on the island. To the north and east is the rift zone, northeast rift zone. It has resulted in about 25% of all the eruptions in the historical period. The middle portion to the upper portion of the rift zone has been active most recently, and in the recent past, lava flows had a tendency to erupt, and the flows head to the north in the general direction of Mauna Kea, then eventually following the natural drainage in the direction toward Hilo. Along the southwest rift zone, the lava flows are distributed more evenly along the entire length of the rift zone, with flows going east and west of the rift zone. Unlike the northeast rift zone, the distal part, The lower part of the rift zone has been inactive in historical period, only the middle to upper portions. Finally, there have been 3 radial vent eruptions, accounting for a small percentage of the historical eruptions. In 1852, a radial vent propagated north of Mokuaweoweo, resulting in a lava flow that bypassed and went in the general direction of the Weather Observatory. In 1859, there was an eruption on the northwest flank of Mauna Loa. It sent lava flows skirting the north and west side of Hualalai, with ocean entries in the vicinity of Kiholo and Keawaiki. And then in 1877, there was a summit phase eruption. There was few hours to days of earthquakes, and then eventually a fissure broke out in the submarine environment in Kealakekua Bay, sending glowing, floating rocks, sulfurous gas emissions, and dead fish. Recent bathymetric surveys have been able to document the vents from this eruption. Flows from different portions of Mauna Loa can travel quickly in some sectors. So different portions of Mauna Loa will result in different periods of time that people have in which they can respond to a lava flow. Lots of people who have seen my talks in the past are familiar with this map. The map shows, in general, the slopes on the volcano. The warmer the colors, the steeper the slopes. For example, if you look at the upper portion of Mauna Kea, you can see these intense red-orange colors. So the slopes are very steep. The large numbers represent average effusion rates in millions of cubic meters per day. And then the numbers associated at the coastline are the transit time of lava flows from their source vents when they open to the flows actually hitting the sea. The other thing unique about South Kona is the distance from the rift zone to the ocean is relatively short. So you have high effusion rates, you have steep slopes, you have a short distance, and that results in rapid advance of lava flows to hit the sea. In general, this sector is a matter of hours in which you have to respond. To the north and east, you have approximately half the effusion rate. More importantly for this area is you have steep slopes up close to the rift zone. Lava flows rapidly advance down to this high area in the saddle. In the saddle there, you have gentle slopes. Lava flows quickly exit from the rift zone down the steep slopes, and they come into this region of low slope. Therefore, the lava flows start to slow down their advance rate. They start to widen, and yet the source vents keep piling up lava and in this area of low slope. This results in there being a logjam situation here, and secondary and tertiary flows initiate. So that's good for the people on the northeast side because you have a division of lava flows, secondary and tertiary flows consuming the volume of lava available. It also results in a slowing down of the advance of the flows in the general direction of Hilo. The one example that's clearly demarked here is the one in 1880-81 eruption, where it took over 280, well, it took about 280 days to reach within the city limits of Hilo. In the case of the radial vent eruptions, we really have only one well-documented case, and that happened in 1859, where the flows started at 11,000 feet, made it down here in the ocean, the A'a phase, in 8 days, and the Pahoehoe phase at Kiholo took over 100 days. So in South Kona, these are all A'a flows, steep slopes, short distance, high effusion rates, really rapid advance times of lava reaching the ocean. Here's a picture looking from Ho'okena into South Kona in the direction of Miluli'i, and you can see the 3 different lava flows from Mauna Loa all arriving at the sea in less than 1 day. In order to simplify the message of the previous slope map, we've decided to color code the response times from volcanic activity into these different colors. The warmer the color, the shorter amount of time that you'll have to respond. Using the high effusion rate, steep slopes, and for shortened distance, you basically in this magenta area will have only approximately hours to respond. As I stated before, there's going to be a summit eruption first. Everybody should be on high alert then. It's possible that if the flows venture into the southwest rift zone, they could be in the ocean in 3 hours. Those of you who work up in the Kona area or North Kona area, and now you have to try and make it to the South Kona area where you possibly live, this will present a challenge. On the other extreme end is the region of Hilo. Because of the moderate to gentle slopes in the highlands, flows have a tendency to slow down and divide, and it will take a very long duration eruption of very focused activity to send lava flows quickly in this region. But using the historical cases, you have weeks to months to respond. So they have a different period of time in which they can deal with a volcanic eruption from Mauna Loa on the northeast rift zone. To the north and west, this area is orange because it sent a lava flow from 11,000 feet all the way down to the sea in 8 days. But imagine if a lower elevation radial vent eruption was to happen instead of at 11,000 feet, at 3,000 or 4,000 feet. It can potentially send lava flows into a region where you may have only hours to a few days to respond. And then on the opposite side, the Kilauea side of Mauna Loa, you really have one example of a lava flow from the northeast rift zone trending towards Kilauea summit. And that was in 1880 also, and it took over a week for lava flows to get here. So we suspect in this area that you will have days to weeks to respond. And the other reason for this color is that this is an area of low population density. I suggest you look at the video for in-depth discussions on this color-coded maps. The other things that we have created are lava flow inundation maps. These maps exist island-wide for Mauna Loa volcano. This is a map for the Hilo area, from volcano down to Kīlauea, out to Hilo, all the way back up to the saddle. These maps were made for emergency response activities and for planning. How are these maps intended to be used? The Hawaiian Volcano Observatory should alert people island-wide that Mauna Loa volcano is erupting. If the dike moves into the northeast rift zone, the Volcano Observatory will provide the elevation and the general movement of lava flows. So in 1984, the lava flows arrived at an area about here, 9,300 feet or so on Mauna Loa's flank. The flows were trending in a northerly direction, which is represented by this burgundy polygon. Waiakea region of Hilo is represented by blue, and from volcano to Kīlauea is represented by pink. So in 1984, these maps did not exist. And so the next view is the view from Hilo. Here is the view from Hilo, where the flows were trending in a northerly direction, and all the people of Hilo, from Waiakea to Kaumana, were looking upslope and wondering if their homes were going to be impacted. And at this point, given this view, all of Hilo was terrified, thinking that lava flows were heading in their direction. Now that we have these maps, we can see that the flows broke out and headed into a northerly direction into this burgundy area. The early flows were actually occupying this area towards Waiakea, but they quickly shut off within a day or so time, and this vent took over and sent flows in this northerly direction. So the people of Kaumana, if the flow had sustained enough activity and duration, enough lava from the ground, could be the portion of Hilo that could have been devastated by the flow. The people in Waiakea now didn't have to worry about lava flows, and they, having had these maps, could look up slope and recognize that they would not have to be planning and possibly not worry at all. And then, of course, the volcano area is in one polygon, and to see an explanation of why all of these communities are in the same polygon or lava flow impact zone, please visit this video for an extended discussion. So, developing a plan. The components for developing a plan is to make a plan, to have an emergency kit, to recognize the hazards, and to sign up for emergency notifications. Now, there are many websites that deal with various aspects of this plan, and I will go through briefly some of the things that are a part of each one of these components. Now, the emergency plan is good for all disasters, not only volcanoes. It's important for hurricane, fire, tsunami, floods, and earthquakes. So this plan can be utilized for all natural disasters. In the plan, you should have contact numbers that you'll need. Should include things as the primary phone numbers of you and your ohana, where they might be. You might want to have people that's out of state that you may want to contact in case the local infrastructure that deals with telecoms is down. So you can call the mainland and talk to a relative who may talk to some other relative of yours. And so that'll be the central locating point. You also may want to have numbers for your doctor, your vet, your insurance. Recognize where the important locations are. Where are you going to meet up with your ohana if you guys are separated? Where are you going to stay? What emergency shelter is available for you? Is it pet friendly? Where is the hospital? Provide this information for every family member. Visit this website to get further details. You may want to have an emergency kit, like quote unquote go bag. And in this go bag, you may want to have identification cards, driver's license. Where are your bank information, your credit card numbers, your insurance? Copies of your deeds and your prescriptions. These are the things that you would pick up in a hurry as you're running out the door as the evacuation is occurring. Now, these are things you want to have pre-positioned before the Hawaiian volcano says that there's an eruption at the summit of Mauna Loa, especially for those of you who live in areas in which the lava flow can rapidly come down the flanks of the volcano. Are you ready? Don't wait till it's too late. This simplified map gives you an idea of how much time you may have to respond. Making a plan is not only good for Mauna Loa or lava flow hazards, but it's good for any emergency. Be prepared. Here are resources where you can learn about Mauna Loa and its hazards. You can see what you might put in your go bag, an extensive list. There are lava inundation maps online where you can learn about the potential elevations and segments of the rift zone from Mauna Loa that can send lava flows into your area. Or possibly where lava flow cannot come to your area. There might be an area announced that's issuing lava. You can look at the map and say, yes, that's me, or no, that's some other community. Visit online and look at videos for discussions on the inundation zones and simplified color maps, what we call lava response times. And then, of course, there are resources online at the Hawaii County Civil Defense website specifically devoted to preparedness, not only of lava flows, but all kinds of natural hazards. Thank you.
All right. Mahalo, Frank Trusdell, for that great summary of Mauna Loa, its eruptive patterns, activity, hazards, response, emergency planning, all of that. What are your thoughts, Dane?
Right. I have a few things just to add on top of it. Frank does an amazing job at this, but he can't cover everything, especially things that are technically outside of his scope. Things like the telecommunication lines, right? There's concerns that we have about, and it's been talked about in some USGS research, the telecommunication lines and the capacity of them, especially the emergency services lines, and what that might entail if, say, all of Kona and everybody in Ocean View were trying to utilize the same same cell phone towers, the same server, or the same services at the same exact time. It'd be almost like a distributed denial of service attack on the infrastructure.
Not to mention,
so that's one thing.
just last week, didn't we have an outage, a communication outage on Kona from construction, and it was just like one wire, and 911 was down because of that, and there was no eruption even happening. It was just regular every day. So that exposes vulnerabilities that do exist. They're there.
Right. So these are also things that not a lot of people will talk about, but they're going to be important come that time. The other one that doesn't get talked about a lot is we know that the lava flows itself can block access to your house, so you can't get back there to do an evacuation or something along those lines. The one that we saw a lot of in 2018 was the authorities blocking access to the house, right? So the house is still there. You still have a clear path to it, and you can't get there. You're not permitted to get there while you maybe have a chance to actually get the evacuation done. So plan ahead to the point of, it's not you're just trying to outpace the lava flow. You're trying to outpace the authorities shutting down access to the area because of the lava flow, if that makes sense.
Right.
It's a lot of games got to be played, and you get one wrong. And I mean, there's guys in 2018 that had everything that they owned put onto a trailer ready to go, and they were not permitted to go and hitch up and drag that thing out of there, even though it was a clear path to their home. No lava there, not permitted. It all went up, in flames. So, don't want to get into those type scenarios. We saw it the hard way. So the preparation is really how you get around that kind of stuff.
Yeah, for sure.
Just
right.
knowing that you have to avoid these obstacles. Like, we didn't even know these obstacles were going to be obstacles type of thing in 2018. Next time, it's going to be more clear-eyed. But there's going to be a lot of people, especially if it's Mauna Loa, that had no experience of 2018 and are going to be going through it themselves fresh. So, preparation is very important.
Really, in hindsight, Leilani and Kapoho are relatively flat. It took a while for the lava to march across and consume everything. I mean, it was painful how slow it happened. It's dragged on day after day after day. I don't see Mauna Loa happening like that, right? It's gonna be moving faster. It's gonna be dividing our resources, our response resources, right? One thing that we've mentioned before is the road gets cut off, and then suddenly, instead of having one team, you have to have one team on each side of the flow, right, to do response or evacuation or whatever needs to be done, kind of thing, right? So taking that concept, right, that if you have to divide your forces everywhere, that makes even less capacity for response. So it's less likely you'll have more than one trip to evacuate your house. You likely have one go at it. And if you're lucky, you might get more. That's how to think of it. Yeah.
Yeah. If you're directly in the line of sight of the thing, definitely. You're only going to get one shot at the thing.
Yeah.
But even if you're not in the line of sight, but you're just in the Trusdell inundation zone.
Right.
It's like,
that's what I mean. Like civil defense and HPD and the fire department, they're all going to have so many bodies to spread around. And it's like, can they really afford to let you evacuate your house and watch you, or do they need to evacuate your neighborhood so they can go evacuate the next neighborhood and then the next one and the next one, and they don't have time to deal with individual houses, kind of thing. That because it's so steep, you really have to hurry up. And
if we're talking worst case scenarios for Mauna Loa, really the 1950 eruption is a great analog for it in terms of the volume, the placement, the speed, the slope, everything. It's kind of like that perfect storm, the 1950 Mauna Loa eruption. But we also, we have a whole bunch of eruptions that are smaller than that. So we're not always preparing or looking at the worst case, but we're preparing kind of for that worst case scenario. If you're looking for the worst case scenario of earthquakes and the earthquake or the eruption sequence beginning until lava coming towards communities, we've been told that's roughly 8 hours, the absolute worst case scenario that people plan for. That's not a lot of time. So that it just goes back into the preparation is the only way you're going to be able to overcome that obstacle.
Yeah, so
That's
I know
not a lot of time.
we talk about it a lot. Like, you know, it's easy to just be like, oh yeah, I'll do that later. Oh yeah, I'll do it later. But you know, if I'll put it this way, and maybe this can kind of wrap us up all together. How we started and ended, right? If this whole earthquake activity on Mauna Loa was worrying to you, or got your attention in some way, right? And you don't have preparations made, then use that as your prompt to go and do some piece of it, right? You don't necessarily do a whole thing. You know, I encourage you to do the whole thing, but like, if you have to do one piece today and one piece tomorrow, then just start at it.
Yep. And also one little last comment about the pets, because the stress, not just for the people, right? Because you're stressed out. There's eruption, there's lava. You're stressed out. You're trying to figure out what to get, what not to get. The thing about it is your pet's going to be stressed too. So you got to anticipate that, where there was a whole bunch of animals that got lost and killed in 2018 just by, you know, the animal ran away type of thing, because while the evacuation was taking place. So yeah, take care of the pets. They're going to be scared too when that thing does come.
Yeah, before it even comes, because the earthquakes are what really, right? The earth starts shaking before the lava comes out, and like that really scares. So if you have a pet, you may consider that you have to call your own evacuation before an authority gives it, because when they give it, it may be too late to go and find your pet.
Right.
It might be too late already, right? So consider that as well, right? Like, you know, what's your threshold? Like, if your pet starts getting nervous, like it's time.
Right.
Even if it's just evacuate the pet first thing, you know, but yeah.
Yep. All right. Well, I think we get through it. Appreciate everybody that stuck around. We do have a decent amount of viewers that stuck through us through the entire presentation. We've now gone over 2 hours, so thanks to everybody that stayed tuned in. We will be back our normal standard time of 5 p.m. Hawaii Standard Time. That is our normal update, and unless something happens, right? If Mauna Loa does something crazy, we're going to go live, and we're going to, bring you an update on that whenever that does happen. But right now, nothing happens. We will be back to you live in 1 week. And that does it for me. Off to you, Phil.
Yeah, and obviously one overnight of earthquakes is not crazy enough to pull us out of bed for that, right? It takes something like we saw back in December 2020, where it was like, okay, lava's coming to the surface. That's the kind of crazy we're talking about, right? Something that hasn't happened, that we haven't seen and been pump faked by over and over the last 10, 20 years kind of thing, right? So if you're wondering if that was a threshold, we did not meet it last week. We were watching closely in case that were to be the case, but it very quickly was not the case. And that was the end of that. So, but we are here, we are watching, and we are listening. So saw quite a few of you guys message us and let us know that earthquakes were going on. So mahalo, keep it coming. Let us know if you see things. We really like the whole crowdsourcing of information, and more eyeballs on it, the better. So thanks for being part of our community, and we're all in it together. And yeah, we look forward to continuing this into the future, starting next week. So until then, for Hawaii Tracker, he's Dane DuPont. I'm Philip Ong.